All right, so here we are continuing to talk about linear equations, but also adding in linear inequalities. This section, I try to do highlights. I most definitely cannot highlight everything that's on this quiz, so please make sure that you've gone through the lesson to see how they set up the things with word problems and stuff like that, because I am pretty much only going to be able to get the main points on here. So in this section, we have the three major forms. In the last lesson, we had and discussed slope, intercept, and point slope. Now we're adding in standard form. So when we are looking at these forms, slope, intercept, we already discussed. The M is the slope, the B is the y-intercept. And then point slope, again, we also already talked about. So I'm just going to write this down anyway, even though hopefully you already know it from the last one. That M is your slope and your y-intercepts aren't there. So it's x1, y1. That's a point. Standard form is different from both of those. Standard form is when I have my x term first, my y term right after it, both on the left, and my constant over on the right side. So this one, you can't look at it and just know any information without doing some actual work. So on this one, there's a couple things that are always true. The slope is always going to be the opposite of A divided by B. So if A is positive, you make it negative. If A is negative, you make it positive. You also can always find the y-intercept by doing C divided by B. Now, I'm actually going to show you a different way to graph it that I think will be a little bit easier when you're trying to identify graphs. But these are tricks that would always work from a standard form equation. All right, so on the first one, I've got two slope-intercept equations just to illustrate. When we actually go to graph them, we start with the b. So on this top equation, my b is 2, so I'm going to go up 2 on the y-axis, and I'm going to make my little dot. Then my slope, m, remember this is rise over run. If there is no denominator, it's understood to be a 1. So it drives me crazy when people say like up this many, over this many. We really shouldn't use the word over because it matters whether it's left or right. So if the top number is positive, that's up. If the top number is negative, that's down. On the bottom, if it's positive, it means to go to the right, and if it's negative, it means to go to the left. So here, when I have negative 3 over 1, that could, because that's also the same as positive 3 over negative 1. So that means from this point, I can either go down 3, right 1, so down 3, right 1, down 3, right 1, and continuing. Or I can also make the 3 the positive and the 1 the negative and go up 3, left 1. But don't say over. Over is nondescript. It doesn't really help us when we're graphing. So here is that line. Then I did a second one here. Y-intercept here is negative 1, so that would be right here. And in this case, my slope is written as a fraction. They're both written as positive numbers, so that means up 1, right 4. So up 1, right 4, and there's my dot. Now, I don't have enough room to go up another 1, right another 4. But again, remember that 1 over 4 is the same as negative 1 over negative 4. So I can also go down 1, left 4, which would be right here. Sorry that my lines kind of look like curves. It's really hard to keep them straight on this software. You are, in addition to being given an equation and identifying the correct graph, also have some where they give you the graph and ask what the slope is or what the intercept is or what the equation is. So make sure that you can work backward too. If you're given the line, you need to count. Pick a starting point. It doesn't matter where the starting point is, and count how many you went up, down, left, or right to get to that next exact point. Obviously, finding the y-intercept, you can see just by looking. So make sure you can work backward too. All right, now I want you to realize that you can directly graph from point slope form. You don't have to switch it over to slope-intercept form unless you want to. If you need help remembering how to switch it over to slope-intercept, go back to the 2.3 instructional video because the last example that I did, I took a point slope equation and I made it into a slope-intercept. So what I want you to realize here is that when we're looking at the moving parts and pieces, I can see, okay, this guy right here is my slope, and that means since it's negative, it can either be a -3 with a +4, or it can be a +3 with a -4, and it doesn't matter which. So either down 3, right 4, or it could be up 3, left 4. Now, these numbers, notice that in the point slope equation, these are minus signs. So y1 is 5 because minus and minus line up. Here, this is not a minus. So that means that I have to change the sign of the x1 value that I see. So x1 is -1. So that means the point is -1 for my x1. My y1 is 5. So I can graph it with just this point and the slope. I do not need to have the y-intercept to graph it. So I plot my point, -1, 5. So 2, 3, 4, 5. So just barely enough room to get that. So it's a good thing I have my slope written both ways because I can't go up. I have to move down. So down 3, right 4 is the one I'll use. So down 1, 2, 3. Now I'm going to go right 4. 1, 2, 3, 4. And then again, down 3, 1, 2, 3. Right 4, 1, 2, 3. It's a little off the page, but I like to have 3 points if I can, just to make it look a little better. So that's how you can graph from a point slope form. From a standard form, what I told you is you can use this, and I'll show you how it lines up in a second. But I think that the easiest way is to use what I call the cover-up method. And the cover-up method is graphing by using both intercepts. So if you take your finger and you cover up this 6x in the equation, so if I'm covering that up, all I see is -3y equals 24. Very easy equation to solve. I divide by -3 and I get y equals -8. That actually is my y-intercept. If I then continue the cover-up method, so take your finger and cover up the -3y in the equation, so that just gives you 6x equals 24. Again, very easy to solve. Divide by 6, x equals 4. This is my x-intercept. So that means I cross the y-axis at the point 0, -8, and I cross the x-axis at the point 4, 0. So 1, 2, 3, 4, 5, 6, 7, 8. Y-intercept, 1, 2, 3, 4. X-intercept. As long as you have at least 2 points, you've got a line, and you most certainly can graph it. Now, if you just really want to always use slope and y-intercept, this that I wrote here will still work. So my C value is 24. My B value is -3, so notice that does give me the same y-intercept of 0, -8. My slope, the opposite of A, so that'd be -6 over B. B is -3. That reduces to 2. So if I had this y-intercept and a slope of 2, I'd go up 2, right 1, up 2, right 1, up 2, right 1, and then what do you know? Up 2, right 1. I land in the exact same place. It's going to give you the same line. So I think the cover-up method is easier, but certainly if you prefer to use the slope and y-intercept trick, you can. All right, so the only other thing I'm gonna go over here are what we change when we have inequalities. Again, make sure you look back at the lesson because of the word problem things you're gonna need to know. But when I have linear inequalities, let's say that I have y is less than 2x minus 5, and then I have y greater than or equal to -2/5 x plus 4. The only thing that we do differently, because these are just like y less than mx plus b, I still have a slope and a y-intercept that I'm going to identify and going to use. So here, in this first example, my slope is 2 and my y-intercept is -5. So draw it on here. And we're going to plot our 0, -5 for our starting point, just like we would if it were an equal sign. So down here, I'm still going to use my rise and run. So up 2, right 1, up 2, right 1, up 2, right 1. But before I draw the line, I have to check. If it's a plain less than or plain greater than, my line that I draw has to be dashed or dotted. So I do something like this. That's the first thing that's different. When you go to connect, you have to check. It will be solid if it has the equal sign underneath. Then we pick a point to test so that we know which way to shade. Now it is in general true that less than shades below and greater than shades above, but sometimes that's hard when you have like really steep slopes to tell. Picking a point always works. I always try to pick 0, 0 if I can, as long as it's not on the line. You can't pick anything on the line. So if I pick 0, 0 and I plug it in, 0 less than 2 times 0 minus 5, 0 less than 0 minus 5, 0 less than -5. So all I have to decide is if this is true or not. Well, 0 is not less than -5. So if it's true, I would shade where that point was. If it's false, shade other side. So since this was a false statement, I'm not going to shade where 0, 0 is. I'm going to shade the other side, which does hold true with below less than. All right, so one more here, and then we're all wrapped up. So my y-intercept here is at 4. And my slope is -2/5. So again, I'm going to be starting the exact same way. So 1, 2, 3, 4. Here's my y-intercept. Slope, I can either go down 2, right 5. So down 2, 1, 2, 3, 4, 5. Or I can go up 2, left 5. Before you connect the dots, check to see if it should be dashed or solid. This has the equals, so it should be solid. And then I pick my point. Again, I'm going to pick 0, 0. So this time I would get 0 greater than or equal to 0 plus 4, which is 4. 0 is not greater than or equal to 4, so I'm not going to shade where 0, 0 is. If it were true, I would shade where that point that I picked was. This time I don't because it's false, so I'm shading up here, which goes with greater than. All right, that's a wrap on 2-4.